My name is Brian Anthony. At MIT, I wear a couple different hats. My academic appointments are in mechanical engineering and in IMES, the Institute for Medical Engineering and Science. I'm the Associate Director of MIT.nano and also the faculty lead for industry collaborations for the Mechanical Engineering Alliance. I finished my PhD at MIT around 2005. While I was a student, I had started and sold a product design company and then a video instrumentation company. So any of the high-speed cameras that you may see in the world that acquire imagery up to 200,000, 300,000 frames per second, around the 2005 timeline were either created and controlled with software or electronics that my company had created. Sold my interest in that in 2005 and came back to MIT to direct our program in manufacturing. That was a program collaboratively developed with Singapore under the Singapore-MIT Alliance. It was an educational program that allows MIT students to connect with companies for the execution of their thesis. We developed that degree program originally in Singapore, and we imported it back to MIT, and that's now known as the Master of Engineering and Advanced Manufacturing and Design program. MIT is an extremely interesting place. Unlike a company where you have to constantly be recruiting people to do the phenomenal things that you want to do, people come to you at MIT. The only difference between the students that are here and me or any of the investigators at MIT is that we've been doing this for a little bit longer. As I tell my students, I want them to be following their passions, and my job is to help figure out a way to fund the things that they want to do and for us to do that collaboratively. I view the students that I work with not as my students, as people that report to me, but as collaborators. They have the best and the brightest ideas that are leveraging the current societal needs, current technologies that are available. It's really the opportunity to collaborate with the students that MIT attracts that makes this place special, not only for me, but I think for everybody here. For example, one of my first graduate students when coming back to MIT was Matthew Gilbertson, a phenomenal machine designer. And we collaborated in the development of a system that would help sonographers, radiologists that acquire ultrasound imagery, to reduce the variability associated with how they acquire the images. We developed, as part of Matthew's thesis, his doctoral thesis, a handheld robot, a 1 degree of freedom linear stage that allowed for automatic and real-time compensation of either sonographer motion, of the motion of the doctor, or of motion of the patient. And that allows us now to collect force-stabilized imagery and eliminate the variability that's inherent in ultrasound imagery, and allows now the doctor to have more repeatable imagery, to get an image at a fixed force, to be able to track a tissue property over time and not be affected by the inherent variability that's introduced by either the sonographer or the patient.